Hello everybody, I'm Alexey Krabarov, the founder and organizer of Bay Area AI. This is our first meetup of 2019. We are here on location at Domino Data Labs, which we've seen grow from a few people at Galvanized to a big company now. They use Scala in the backend and they serve data scientists in the cloud. And so we're very happy to be here on location. Our first speaker is Omar Alonso, who's a principal software engineer at Microsoft. And he is a veteran by the Bay events. He talked about data by the Bay before, and so we're very happy to have you here, Omar.
Thank you very much for having me, Alexey.
So can you tell us a little bit, basically what your focus is and what have you been doing for the last couple of years?
Sure. So my interest is mostly on the intersection of information retrieval, knowledge graphs, and human computation. Mm-hmm. And we've been working obviously with a lot of social data. And the last 2 years, we've been doing a lot of knowledge graph extraction from different sources, not only Twitter, but also other Microsoft data sources. Mm-hmm. The talk today is one of those projects. But it's mainly about unsupervised generation of knowledge graphs.
Mm-hmm. So I think you had given talks about label quality at our previous event. And I think that was one of the really foundational topics. So I'm curious, how did you come to that area? What is it about data quality which attracted you?
One of the reasons is if you want to play with new data sets like information retrieval and you want to work on search, at some point you have to do evaluation. Mm-hmm. And if you don't have ground truth, it's very difficult to build those data sets. And when I was at A9, I learned Mechanical Turk and mm-hmm. I got hooked into the idea of doing labeling in general. That's how I got to do labeling. That's how, by the way, I gave the talk, and thanks to you, by the way, I'm trying to finish a book on labeling. Uh-huh. So thanks, Alexey, for the invitation, because that kind of spurred trying to put all these slides together in a short monograph, which is mostly about the practice of labeling. Mm-hmm. There's a lot of publications on how to do labeling, but the bulk is how to do this at scale, mm-hmm. and involves learning how to design your HITs, your human intelligent tasks, and then based on the domain, applying different techniques. That's mm-hmm. basically the practice.
So this is, I think, when you did this talk, the whole AI wave was not as high as
today, yeah.
Right, as it is today. And now I think we actually see very relevant examples, right? Because the trust in machine learning now, I think more people understand. And I think there were mainstream media articles about bias. Right, so if AI is trained on certain kind of people, it will not understand other kind of people, their voices, right, like their characteristics and so forth. So I'm wondering, do you find that people understand that it all comes down to the data originally? Did you see more people asking you about this, whole end-to-end data quality pipeline?
Yes. So the answer is yes. People are getting more interested in how do I build training sets? How do I assess the quality of my machine learning models, AI models? At the same time, biases is a new thing that is coming up a lot. And last but not least, the notion of annotations mm-hmm. on labeling data sets. Mm-hmm. Because sometimes you don't know how you gather these data sets.
Right.
So annotating was the sampling methodology, which areas you touch, et cetera, is usually not even thought, and it's becoming crucial because mm-hmm. you want labels, you want clean data sets, and then you not only want to know how biased the data set is, mm-hmm. but also you want to know all the annotations. So if you want to reproduce another experiment, so you need to refresh a data set, mm-hmm. you have to have all the different knobs that you used to build this data set, mm-hmm. which in the past was like God gives Alexey the data set.
That's right.
And that's good. Now it's like you have to derive these data sets over and over again for many different properties and domains.
So, what comes to mind is, right, let's say with this whole fake news phenomena, yeah. right? Obviously news, people have different opinions. So if you want to ask a bunch of people to label political tweets, Russians will label them very differently than Americans.
Correct.
And Russian Americans will label them different from either of these groups.
Yes.
Right? And so I wonder, do you find, do you try to compensate with this? Do you want to understand what biases, humans have biases? And do you want to go back to them and understand what biases they could have had? Like how, like, do we have to understand biases in humans? Like, do we have to go back all the way and try to model?
I think what you need to do if you're going to build these data sets is to get an idea if the task has a subjective answer, an objective answer, or somewhere in the middle. So if the task is about building objective answers, then you can get agreements and compute integrated coefficients, etc. There are certain things like elections, Democrats versus Republicans, fake news versus not fake news.
Right.
Those tend to get much harder. So it's difficult to get full agreement, but what you want to know is if you sample different times, the proportions are stable, which means like, well, if 2 out of 5 think it's fake, always, maybe there's something there. But in one sample, nobody thinks it's fake. So on the next one, everybody thinks it's fake. And then there's something fishy there.
Right.
So it's more about trying to find those tasks where things you're not going to get agreement on it, and then do something with it, versus blindly, either blaming the data set or the workers or the interactions, which is usually what is done in practice. Instead of understanding the nature of the problem. Fake news detection is hard because, like you said, if you think in terms of US versus Russian politics is one thing, but if you say fake news about, say, Brexit, maybe it's a whole different thing.
Right.
And maybe people may get more agreement on fake news in Brexit versus politics in the US.
Right.
So understanding that, I think, is kind of the precondition for doing the rest.
Right. And fake maybe, I mean, if there is an objective truth, like something happened and the news is wrong, then you can say it's fake. But if something is political opinion, right, it can be actually a question, because somebody's fake news can be real news to some other people, right? And that, I think it's super hard.
Correct. And also fake for you may have a different definition than for me. Maybe you find the news that is so fake that is hilarious,
right?
Versus how another person, say in the Midwest or in the East Coast, will get offensive by this.
That's right.
So understanding how humans will answer to the question, is this fake or not, is also very important. So you never have to take it for granted and say, oh, just go and grab some fake news data set, because it's always going to be very difficult.
Yeah, so it's so like that's the ground truth. But now you are into knowledge graphs.
Yes.
So how do you move from labels to knowledge graphs?
It's an internal project, so I've been working on. The reason why I got into labels is to leverage human sensing, and with social data, say Twitter or Facebook, there's a lot of human computation at scale. So why not just deriving graph from that sensing? So if everybody is doing today, instead of like counting hashtags and trending topic, can you derive a graph? If you have a lot of link sharing within a social network, can you derive something else? So it's basically aggregations that you can do that are just beyond counting terms or topics, and if you can derive these connections. Has a lot of labeling.
Yes.
Labeling is also hard because now you have to label the quality of the graphs, but it's kind of like the next step on labeling, from my perspective, in my own projects.
Interesting. So knowledge graphs is an established area, right? And so, and if in my mind, it is like what comes to mind immediately is RDF and Semantic Web.
Yes.
And it's kind of, it was cool for some time, but not recently, right? I think there was like at some moment before AI, before like a modern kind of fashionable AI, right? There was a notion that like at some point it looked like we'll build Semantic Web, and everybody's gonna very like painstakingly annotate the websites with RDF protocol, and there will be semantic triples everywhere, and it didn't materialize, right? Like it's really, I think the feeling like so there are some like hardcore veterans who still do that, right? And I think like I've seen a lot of work from German universities, and I think they can still like cataloging everything. But where is this field? I met people from Google. I think Eugene Gabrilovich was doing knowledge graphs, right? So, but I think they do like internally they do some health modeling. So, but I don't see like mainstream companies talking a lot about it. Like, what is this still a very like? But I know it's used internally. I just don't know how much of it is proprietary, how much of it is open research. Like, what's the state of knowledge graphs in the knowledge database?
Great question. So our approach to knowledge graph is not the traditional AI, what you just mentioned, but it's basically more like domain-specific graphs, which have some knowledge on it. You mentioned Eugene, who is at Google. Google has this Google Knowledge Graph. Microsoft has the Satori Knowledge Graph. And other companies like Amazon, they're building their own knowledge graph for products. Pinterest is also building their own knowledge graph for
right across the street.
So you can think of like little graphs that are just specific for a domain, say entertainment, business, etc. So the goal here is not to capture the worldview. So that'll be kind of the psych and all those projects, but it's more like for a specific domain, say music, who are the bands, who are the players, who are the genre, etc., and have all these connections, if possible, automatically derive. So it's more about a data-driven approach to detect entities, entity resolution, linkage, etc. That then you can expose as a graph with annotations. You can call it a knowledge graph. That's how we call it. It's not like a super, the worldview of the planet, but it's a good representation of a specific domain.
Interesting. And so this comes from original questionnaires, or is it derived automatically? Like, what do you need from humans? The labels are human, right?
Correct. So in the case of the SKG graph that we'll talk today is about detecting links, people, topics from Twitter automatically. If you detect that and make a few connections, you can build some pretty interesting applications. You don't have to go full-fledged into super crazy techniques, which is understanding people, places, organizations, links, topics, and then make the connections via co-occurrences or anything else, and you can have a pretty decent graph. I say graph. We could call it a knowledge graph because it has some knowledge in it, but it's not RDF, and we don't really care on the representation of it. It's mostly like which are the different entry points you can choreograph and get data around it that before was difficult. In the example of Twitter, we can see what people say for the US elections 2 years ago, before the US elections, which is something that's difficult to see today in Twitter. This is just by building these little artifacts.
Interesting. So it's kind of domain-specific knowledge graphs.
Domain-specific knowledge graph, perhaps is a better terminology, is lightweight. Let's put it this way: lightweight KVs, which are not super comprehensive. I mean, as an encyclopedia like Wikipedia, but it's very good at the domain.
Are they hierarchical or are they flat? So people on topics, right? So this is one level. Do you have a hierarchy of topics?
Well, so for the one that we'll present, we don't. But if you have the baseline well done, then aggregations are somewhat easy to build, and I'll show a couple of examples on those aggregations, which is the point of building this domain-specific knowledge graph. It's like the aggregations that you can build. So it's not about the data, information, knowledge. That pyramid is mostly like, if you have these little connections, what can you do? Versus I don't have the connections, therefore it's difficult to do this.
Interesting. So I want to kind of shift gears a little bit in a sense there may be a connection, maybe not, but let's see. So I talked to Francois Charlotte, who is the Keras creator. He's at Google, and he's a Google brain, right? And I talked to him about deep learning beginning of last year, which was like the peak of kind of deep learning is going to solve everything, right? So basically, and he was very interestingly, he kind of was saying that deep learning will never be general artificial intelligence. He basically was saying it's not capable of generalization because it's very good with pattern detection, right? But it will not generalize. Like if it give you different kind of some different kind of stripes, if you give it a completely new kind of stripes which are not of the kind it saw, it will not understand it. And so he was actually talking about that we need a fusion of statistical AI and logical AI, and I think Stuart Russell at Berkeley talked about that as well. So basically, that like they're hinting at there is like the limit of statistical AI, which we all are doing right now, and there needs to be some combination with what used to be called kind of traditional AI, right? So we have this knowledge bases or something else. But basically, like I was surprised to find, among the kind of cutting-edge people in deep learning, the feeling that you need something else to go to the next level, and so I wonder, like the work you do, is it related? Can it be kind of automatic, like building knowledge bases? Like basically, we need world knowledge in some way. We need something else than besides deep learning. is this a possible complement to deep learning, or its own kind of specialized area? Do you see any interaction?
So for the record, I don't know anything about deep learning, so can't comment on that front. One of the reasons why we've done this bottom-up and supervised is going back to one of the other points you were mentioning, is about explainability. So if you want to detect that Alexei is, related to, say, Domino's Labs or something, how can you explain those relationships? And sometimes a bottom-up approach and unsupervised, you can explain some of these things. That's one of the reasons why the project that I'll show today on Twitter is bottom-up, because we want to be able to explain why this thing is related to that. And the other thing is provenance. We want to show evidence that these two things are related. And if we can sprinkle the data set with provenance, which is a well-understood topic in databases, then you can make sense of this. Versus, this thing is related because it's magic. This will be it's related because here's what we believe is a relationship. So slightly, maybe there's a connection, I don't know. This one is bottom up, that's what I'm trying to explain.
Okay.
Unsupervised and from the ground up, grassroots if you want to call it. Kind of a lightweight KBs.
Interesting. Yeah, I'll let our viewers to infer the connection if there is anything, and comment under the video when they see it. Cool. So we're definitely looking forward to your talk. But like overall, where is your research going, and like what are your plans for this year? If you can kind of briefly summarize.
So for this year, Dub is going to be here in San Francisco. In May, I'm running with co-chairing with Edith Law the Human Computation track, which we have some super papers. The conference is going to be massive, so if you can attend, please attend. In October, helping out with HComp, the Human Computation Conference. It's going to be in Portland, near the border with Washington State. The rest, we have a few things on Knowledge Graph that we would like to, if we get approval from Microsoft, to publish. That's it. We've been like under the covers in the trenches trying to ship some products. So
that's super exciting.
not a lot of research. Everything that I'll mention today has been already published, and the rest is like working hard to put it externally at the moment.
And it's great to hear because we in the community we have, for instance, Figure 8, formerly Crowdflower, which do a lot of human computation. Right? So I think this topic is actually kind of very interesting to a lot of people in this community. So it's great to have you here. Looking forward to your talk.
Thank you very much for the invitation.